All right, number 3. Here we have h of x equals x cubed plus 1 over x squared plus 2x. All right, so the first thing we're going to do is we're going to factor this thing. All right, so notice on top we have a sum of perfect cubes. All right, so when we factor that, we'll get x plus 1 times the trinomial x squared minus x plus 1. Factoring the bottom, pull out an x, and we should have an x plus 2 in parentheses. All right, we'll hold it right there, and we'll take a look at that domain now. All right, so that's where the denominator does not want to be 0. All right, so I've got an x all by itself, so x should not be 0. And then I've got that x plus 2 that also should not be 0. So x should not be negative 2. All right, so writing your domain, just make sure you get your numbers in the correct order, right, from smallest to largest. All right, there's your domain. All right, now we're going to go back up, and we're going to just make sure this thing is factored before we move on. Make life a little bit easier for the rest of these things here. So we're taking a look at that, the red there, and we notice that we cannot slash anything out, right? So this is reduced. I'm going to make a note of that. All right, now I'm going to move on to the x-intercepts, and that's where we let y equals 0, right? But since this is a rational function, we're starting to learn that as long as the numerator equals 0 here, that makes the y, that makes the whole function equal to 0, and we're good to go. And not only that, but since this is reduced already, even though we factored it, we could actually use the original function. Might be a little bit nicer to deal with. So in other words, the numerator, I could use x cubed plus 1 and set that equal to 0, which means x cubed equals negative 1. And the only thing that you could cube to get a negative 1 is negative 1. And so our x-intercept is negative 1, 0. Okay, so for the y-intercept, it's kind of the opposite technique, right? We're going to let x equal 0. And again, you can just use the original. Since it is reduced, its simplest form, even though we factored it, we couldn't slash anything out. So it is, the original is in simplest form. All right, so what we could do is we could say that y equals 0 cubed plus 1 over 0 squared plus 2 times 0. And when you do that, you notice that you're going to have a 0 in the denominator. In other words, this is going to be undefined. And since it is, that means, in this case, we have no y-intercept. All right, so let's take a look at the asymptotes now. Vertical asymptotes where the denominator equals 0. And after doing a few of these, we've now discovered that as you're finding your domain, it's kind of helping you with your vertical asymptote, isn't it? All right, so x equals 0 and x equals negative 2. Those are going to be our two vertical asymptotes for this problem. And now we're going to look for the horizontal or the oblique asymptote. So let's take a look at the degrees of each of the polynomials here. We've got x cubed plus 1 over x squared plus 2x. And we notice that the degree of the numerator is bigger than the degree of the denominator. Also, it's bigger by 1 degree. That gives us an oblique asymptote. All right, so we're going to have no horizontal asymptotes. But we do notice, once again, that the degree of the numerator is greater than the degree of the denominator by 1, which creates an oblique asymptote. I'm going to hold off right there, and I'm going to do a separate video to find that oblique asymptote for you, okay? So let's go on to the next video. It'll be nice and short for you.